Effesus is a research project that investigates the energy efficiency of European historic urban districts and develops technologies and systems for its improvement. The Effesus Consortium unites 23 partners from the academic sector and industry, as well as municipal authorities from 13 different European states. The project is funded by the European Commission under its 7th Framework Programme.
The main motivations come from the fact that we need to reduce the energy consumption and CO2 emissions in Europe, and more than 40% of energy consumption is due to the buildings. In fact, more than 25% of our buildings have been built before 1945. So our motivation to create the Effesus project is, on one hand, to contribute to the energy efficiency, and on the other hand, to promote the conservation of our historic cities.
Within the Effesus project, we developed several technologies and also products. We developed insulating mortar, which can be used on the outside and inside of outer walls to avoid heat losses from the building.
The innovation is that the lime-based mortar is compatible with a wide range of historic building typologies. It is permeable for vapor, and its modulus of elasticity is compatible with typical historic substrates and allows for the necessity of deformations.
The next product is also addressing insulation, which is an aerogel insulation, which can be filled in cavity walls.
The main purpose within Effesus was to realize a retrofit application of advanced aerogel as a blown-in insulation behind the plaster or plasterboard finishes on a traditional solid wall construction. The insulation is insensitive to moisture and is highly permeable. It provides a maximum of thermal resistance and is in a form that can be injected into the small cavity behind lath and plaster.
And then we also address the building fabric by infrared reflective coating.
The new Effesus developments are based on salt gel coating technology with specific IR protective additives. The radiation selective coatings are to reduce solar heat gains in the building envelope. Transparent solutions that do not in any way modify the external visual aspect of the facade have been developed in addition to intransparent formulations, which fulfill the requirement of reversibility from relevant historic wall materials.
As well, we address windows, as through windows we have lots of ventilation losses.
In the case of historic buildings, the visual impact of alterations in fenestration can be significant. The Effesus intervention consisted of the replacement of 2 traditional double-sash windows, together with new ventilation valves on the frames, the installation of new blinds, an exhaust fan, and intelligent indoor climate solutions. The main output of the Effesus project is a decision support system, an innovative software tool for the assessment of energy-related interventions in built cultural heritage at building and district level. The DSS inputs come from several components, including the Historic Buildings Categorization Tool, the Energy Efficiency Solutions Repository, and the Multiscale Data Management Model. It has been developed to help users to select and prioritize energy interventions, while maintaining full respect towards the historical significance of the buildings. The main target group of the Effesus DSS are the municipalities and urban managers responsible for improving the sustainability of historic districts.
The project will impact in different aspects. First of all is the environmental impact, because we are reducing significantly the CO2 emissions and energy consumption that are linked to buildings. But also we will create economic growth, because new SMEs are needed for a new market. And also the project will impact on trying to revitalize historic cities, and it also has an important impact on the society, because we are trying to create economic growth inside the historic city and also to promote tourism.